All right, welcome to part 2. So now we're solving for x, but in order to solve, I still have to factor. So I'm looking here at the x squared plus 11x plus 30. If I go ahead and just do my x up here to factor it, I've got a 30 here and 11 here. So what times what is going to give me 30, but add to get to 11? Well, that's going to be 5 and 6. So I've got x plus 5 and x plus 6 equals 0. That means I need too many equations, either x plus 5 equals 0 or x plus 6 equals 0. And if I just solve those, which I just do the opposite, I'm going to end up with x equals negative 5 or x equals negative 6. Okay. Same thing here. The only difference is this x is on the other side, so I have to add it. So where I have x squared plus 7x plus 12 equals 0 now, because it has to be in the form of ax squared plus bx plus c equals 0. And then I can do my 12 and my 7. So 3 times 4 gives me that 12, and it adds to get to 7. So I have x plus 3, x plus 4, equals to 0. So that means either x plus 3 equals 0 or x plus 4 equals 0. If I solve each of those, x equals negative 3 or x equals negative 4. Okay. This one, we don't have it equal to 0 either, but I have 3x squared minus the 4x and minus 12 now equals 0. I have a do it wrong. Well, first of all, I better make sure, do I have a GCF? Well, 3, 4, and 12, no, I don't have a GCF, but step 0, I need to remember that. All right, so negative 36 here, because 3 times 12, and then negative 4 here. So I'm looking at, one of them's going to be negative and the other one positive, because I end up with a negative multiplying and a negative answer. My options would be 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. So 1 and 36, 2 and 18, 3 and 12. I'm trying to get to 4. Let's see, 4 and 9, 5, 6 and 6. I'm not seeing any of them that are going to work. So this one is not factorable. We are not going to say it has no solution, but it's not factorable at this point. Again, if you catch me on something and you see something else, you need to let me know. But 1 and 36, if I add those, I don't get 4. 2 and 18 would give me the 16. 3 and 12 would give me 9. 4 and 9 would give me 5. And then 6 and 6 would be 0. So no, we're good to go here. Okay, so jumping down to number 8 or 18, it is equal to 0. So I see a common factor of x. And if I pull out an x, I'm left with an x here, because x times x would give me x squared, and plus 8 here to give me 0. And if I factor that back in, I end up with ax squared plus 8x. Well, here's the thing. I've already factored it. This is factored. These are my two pieces. Either x equals 0 or x plus 8 equals 0, which means that x equals negative 8. So my two options are x equals 0 or negative 8. All right, we got to get this one equal to 0. So 2x squared minus 3x minus 27 equals 0. All right, I'm going to come over here. I've got negative 54 and negative 3. So I'm looking to see what multiplies to get to 54 and adds, or negative 54 and adds to get to negative 3. Well, we have 1 times 54. We have 2 and 27. We have 3 and 18. We have 4 doesn't work. 5 doesn't work. 6 and 9 work, however, so that makes it perfect. So I need negative 9 and a positive 6 to give me my negative. So I'm going to do it wrong. 2x, that's a square by the way, 2x minus 9 and 2x plus 6. And I've got to see if I can fix it. Well, I have to be able to. This one can be simplified to just be x plus 3. So I still have 2x minus 9, though, because I can't simplify that, and that equals 0. So now I'm ready to set each piece equal to 0. So 2x minus 9 equals 0. X plus 3 equals 0. Well, this one's easy. X equals negative 3. This one, we have a two-step equation, so I'm going to add 9. So I have 2x equals 9, and then I can divide by 2, so x equals 9 halves. Or this negative 3 up here. So that would be my solution for this, is the x equals 9 halves or negative 3. Okay, this one's already in the form of x or it equal to 0, ax squared plus bx plus c equals 0. So I've got negative 60 here and negative 7. Well, 12 times 5 is going to give me 60, and when I subtract those, the negative 12 and a positive 5, I end up with negative 7. So do it wrong. 10x minus 12 and 10x plus 5, and they're equal 0. I can fix it. This one, both divisible by 2, so I end up with 5x minus 6. And this one's both divisible by 5, so I'd have 2x plus 1 equals 0. I'm going to set each one equal to 0. 5x minus 6 equals 0, and 2x plus 1 equals 0. Add 6 to both sides. So 5x equals 6. Divide by 5. X equals 6/5. Or the other option, subtract 1 on each of those. 2x equals negative 1. I can divide by 2. So x equals negative 1/2. Yes. So either 6/5 or negative 1/2. All right, this last one. And yes, there is going to be one on the test like this, so hopefully you are paying attention, doing what we need to do. Here's what it tells us. It says factoring can be used to help simplify fractions with trinomials in the numerator and denominator. We have to factor both the trinomials and simplify the fraction by canceling out common factors. Now, I can't look here and say, oh, I've got a 2x squared and a 2x squared, so I must be able to cancel those out. No, because of this plus sign right in between there. And so it's not a factor yet. It's because factors are pieces that we multiply. It's not a factor yet. So we have to look at these as two separate problems. Basically, let's look at the numerator and let's see if we can factor that. So I would have my 2x squared plus 11x plus 15. So if I factor that, I've got this 15 here, and or no, I don't. I have 30 because I have to multiply those. So I have a 30 and an 11. And we said 5 and 6 because we did this one already. So if I do that, I've got a 2x plus 5 and a 2x plus 6, but I can simplify this 2x plus 6 to be x plus 3, and then the 2x plus 5. That is my numerator. So this becomes my new numerator of being the 2x plus 5. There's one factor, and x plus 3 is the other factor. All right, so let's take a look at the other one. So the other one we have, it's 2x squared plus 15x plus 25. And if I set up my x box for this, I've got a 50 and 15. Well, 5 times 10 gives me those two things right there. So if I do it wrong, I've got 2x plus 5 and a 2x plus 10. Well, this 2x plus 10, I can simplify. I can divide both of them by 2, and I end up with x plus 5. So I have a 2x plus 5 and an x plus 5, and those are my two factors for the denominator. So that then in turn goes down here. I have 2x plus 5 and an x plus 5. So we have factors now. And if you notice, this factor right here of x plus 5 is the same thing as this one right here. So like a fraction, which is what it is, we can simplify this by canceling those two out. So our answer to this, because x plus 3 and x plus 5 are two different things, so we're going to leave those. Our answer to this is just x plus 3 over x plus 5. So this trinomial over a trinomial can simplify down because they have a common factor, and we can get rid of those. So we just end up with x plus 3 over x plus 5. Again, there's one on the test like this, so hopefully you're understanding, making sure you're figuring out, gotta factor, and then try to get rid of. We can't do it if they're separated by the plus or minus. Come in and ask questions if you're lost. This was part 2.